Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about systems of equations and solving them by graphing. And up at the top here I put a definition for what a system of equations is. And recall that a solution to a system of equations is any ordered pair that makes all of the equations true. Another way you could say that is any ordered pair that satisfies all the equations in the system. That is a solution. So with that in mind, we're testing the ordered pair here, 2, 7, to see if it's going to be a solution to this system of equations. So we substitute the 2 in for x and the 7 in for y, and then we multiply it to get 6 plus 14 equals 20, and we continue to evaluate, and we get 20 equals 20, which is in fact a true statement. So we've passed the first equation. Now let's see if that works into the second equation. So we're going to substitute the 2 and the 7. We're going to evaluate, add them together, and you get 54 equals 30. That's actually a false statement. So that tells us that the ordered pair 2, 7 is not a solution to this system of equations. Now, if we were to try a different ordered pair, in this case, let's try 6, 1. Again, we'd just substitute the 6 and the 1 for x and y. We'd evaluate, and we'd see that 20 equals 20, which is a true statement. So that passed the first one. Now let's take a look at the second. We substitute the 6 and the 1 in for x and y. And then we say 24 plus 6, and that's 30 equals 30, which is a true statement. So now that tells us that the ordered pair 6, 1 is a solution to the system of equations. Now, to be able to find that solution, we don't want to just guess random ordered pairs. We want to have a systematic way of approaching that. And what we're going to do is we're actually going to use graphing to do that. So let's talk about, there are 3 possible solution types for a system of equations. So one of them is where you have one solution. And algebraically, that's where one ordered pair satisfies all the equations, which is what we just looked at here with the ordered pair 6, 1. And graphically, that's where you have one point that all the lines on the graph share, or where they all intersect. Okay, the second type of solution is infinite solutions. And algebraically, that's when all the variables are eliminated, the remaining statement is true. And graphically, that's where the lines on the graph are all the same. And then the third type of solution is no solution. Algebraically, that means when all the variables are eliminated, the remaining statement is false. Or graphically, that's where the lines are parallel, which means that they will never intersect because they have the same slope. Now recall, for graphing, you want to have slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So to solve this system of equations by graphing, we first need to have the blue and the red equation in slope-intercept form. So to do that, we have to isolate y. And to start that in the blue equation, we're going to add 6x to both sides. And then we're going to use the 2y equals negative 4 plus 6s. We're going to divide everything by 2. And that's going to leave us with y equals negative 2 plus 3x. Okay, we also need to do that isolation of y for the red equation. So we're going to start that by subtracting 3x from both sides. And then you're going to divide by 3 on everything. And that's going to leave us with y equals negative 6 minus 1x. Okay, so there's an understood 1 here next to this x. So now we can take those two equations and we can start to graph them. So let's look at the blue one first. The blue one, we're going to start with the y-intercept of negative 2, and it's going to have a positive 3 slope. So you're going to go up 3 to the right 1, up 3 to the right 1, or down 3 to the left 1. And then you just connect those dots with a solid line. Then we graph the red equation, and that's going to have a y-intercept of negative 6. So you can see that point right here. And the slope here is negative 1. So you're going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And you can see that the two lines actually intersect at this point here that's purple. And so what we would say is that there is one solution here, which is negative 1, negative 5. And that's our type 1, one solution. All right, let's look at a second example where we say solve this system of equations. And again, we're going to try and isolate the y to get these two equations into slope-intercept form. And so doing that, we're going to start by subtracting 6x from both sides. And then we're going to divide everything by -9. And that's going to leave us with the equation y equals 2 plus 2/3 x. That 2/3 just comes from 6/9, which reduces down to 2/3. So now let's look at the second equation. We're going to isolate the y. Subtract 4x from both sides. That gives you -6y equals -12 minus 4x. Divide everything by -6, and then you're going to be left with y equals 2 plus 2/3 x. Now, just looking at those two equations right now, they're exactly the same. So when we go to graph them, we are going to see that they're going to overlap each other. So the first equation, the red, you have the y-intercept of 2 and the positive 2/3 slope. So that means you go up 2 to the right 3, up 2 to the right 3. And then the second line, the blue line, is just going to be laid right on top of it because it's the exact same equation. So what that means then is this is type 2. This is infinite number of solutions. And then let's look at example 3. Again, we're solving the system of equations, and we want to start this by isolating the y to get it into slope-intercept form. So we're going to start that by subtracting x on both sides, and then we're going to have dividing by 2 on both sides. So that's this step. And then you're going to say y equals -3 minus 1/2 x. Then we're going to isolate y in the red equation by subtracting 3x from both sides. And then we're going to divide everything by 6, which is going to leave us the equation y equals 5 minus 1/2 x. So if we go to graph this, we can see that they both have the same slope of a -1/2, but a different y-intercept. So let's go ahead and graph the blue one first. And we're going to start that at -3 on the y-axis because that's our y-intercept. And the -1/2 slope means you go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, so on and so forth. And then the red equation is going to have a positive 5 y-intercept and a -1/2 slope. So go down 1 to the right 2, down 1 to the right 2. And notice, since these are parallel lines, they have the same exact slope, they will never intersect. So this is our type 3 where we have no solution. And let's go ahead and look at a fourth example. So in example 4, we have one equation here in blue that's going to be a vertical line. We'll see that in just a moment. And we have this red equation where we need to isolate the y. So we're going to start that by subtracting 5x from both sides. And then we're going to divide everything by 5 so that y equals -x. Now this looks like a goofy equation, but if you follow the slope-intercept form, we're going to see what that looks like here in just a moment. So we start with graphing the blue equation first, and that's going to be a vertical line at x equals -6. And if you think about it, all the ordered pairs on this line all have an x value of -6. So this ordered pair, this ordered pair, this ordered pair, and all the ordered pairs in between here, which is what this equation is representing. Now this red one, you have a slope of -1 and a y-intercept of 0. So notice we started the y-intercept at 0, 0, and we have a slope of -1, which goes down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, so on and so forth. Okay, now where they intersect is that point right there, which they share that solution, and that's the ordered pair -6, 6. And then lastly, example 5, here we have an equation y equals 4 that's already been isolated. And then we need to isolate the y in the second equation. So we're going to do that by adding 6x to both sides and then dividing by 3. And you're going to get y equals 2x. And now if I try and graph these two equations, I get the horizontal line at y equals 4. So think about this. This means all the y values on this line, all the ordered pairs have 4. So this has a y value of 4, this has a y value of 4, this has a y value of 4, so on and so forth. Okay, so a horizontal line. And then in this equation, slope-intercept form, the slope is positive 2, and the y-intercept is 0. Okay, so there's the 0, and the slope of 2 means I go up 2 to the right 1, up 2 to the right 1, up to the right 1. And it looks like the two lines share this ordered pair here, which is the solution 2, 4. And this concludes our video lesson.